130 centimetres cubed of oxygen and 40 centimetres cubed of nitrogen, each at 298 K and 100 kilopascals, were placed into an evacuated flask of volume 0.5 decimeters cubed. What is the pressure of the gas mixture in the flask at 298 K? So the way this question is written, it's tempting us to try to use PV equals nRT, but we don't need to. And they haven't given us the gas constant R either. So we're actually going to be using a ratios method. There was 170 centimetres cubed of gas, and that had a pressure of 100 kilopascals. Okay, and then the volume of the flask, it was put into this volume of this flask, and the volume of the flask is actually 500 centimetres cubed. It's got bigger. So how much has the volume of the flask increased by? So 500 divided by 170. So the flask has increased by 2.94. Okay, so what would that do to the pressure? Yeah, so because the flask has got, the space in the flask is bigger than the volume of the gases expand out, the pressure will decrease by the same amount. So we want to do 100 divided by 2.94, and we're going to get 34 as the answer on the calculator. Okay, so the volume was times by 100 and 2.94, so the pressure would be divided by 2.94, because in PV equals nRT, if the temperature and the moles and the R are constant, then if V goes up by 2.94, then P needs to go down by 2.94. When we do that, 100 divided by 2.94, we get 34, which is answer C, so we pick answer C.